Welcome back to our YouTube channel. Today we are going to discuss about what the first row, the first series of transition methods. So, firstly, I wanted to discuss on transition methods. What are transition methods, and also what are D block elements. So, these two words, transition methods, and also the term D block element. Go. Sometimes these two terms are used interchangeably. But transition methods does not fully means D block element. And also D block element does not fully means what? Transition methods. Each terms here has its own specific definition. Now, for example, the word transition methods. Transition methods, these are elements or methods that have incomplete or partially filled D subshell, either in the atomic state or in their ionic state. While D block elements, these are elements whose last electron reside on D orbital or D subshell. So now, I will say that transition methods are elements that have incomplete, or we can say that partially filled D subshell, either in the neutral or ionic states. While we can say that a D block element, D block elements are elements whose last electrons reside on D subshell. So now, with these two definitions, we can clearly understand that these two terms, transition methods and D block element, are not the same. These are elements that have incomplete or partially filled D subshell, either in their neutral or ionic state. While D block elements are elements whose last electron reside on D subshell. So now in this case, we are going to talk about the first series. I think about the first series, that is the 3D series. Now, in these definitions, we know that D orbitals carry the maximum number of 10 electrons. Now, this carry the maximum number of 10 electrons. So now, this means that a transition metal, I will use Tm to indicate the word transition metals, will start from D orbital that contain 1 electrons to D orbital that contain at least 9 electrons. This definition falls, the definition of transition metals falls in this range. Those that have 1 electrons up to 9 electrons. Because we say that are elements that have incomplete or partially what filled d orbital. So this means that any element that falls, whose electron configuration fall within this range is a transmitter. But now, a d block element, a d block element now, the configuration falls between what d1 to what to d10. Meaning, even if an atom have what the maximum number of electrons that d orbital can occupy, is still belong to what to d shell, to a d block. It's a d block element. But when it has d10, this shows that this element is not a transition metal. Now, for example, that is why we say that all transition elements are d block elements, but not all d block elements are what are transition elements. Now, for example, the first series start from what? From scandium to what? To zinc. Scandium number 21, zinc number what? 30. Zinc in this case has what? Has D10. This means that zinc is a d block element, but not a what? A transition element. Because in definition, this D does not fall under the banner of what? Of this one definition. So this means that any element that has configuration ranges from 1 to 9 is a what? Transition metals. But when the D is complete, meaning it has a number of 10 electrons, this shows that this element is not a what? It's not a transition element. So now, from here, since we are talking about the first series, the first series. Now, let us look into the electronic configuration. Electronic what? Configuration of the what? First series. The first series, we are talking about what? The 3D series. They have an electronic configuration of a noble gas core into what? NS2 into what? N minus 1 d to the power of x. This n is what is Preston quantum number go. So now in this case, for the first series, for the first series, that I want the 3D series, all these elements from element number 21, meaning from scandium to what? To zinc, they belong to what? To period what? To period 4. To period what? Period 4 in the periodic table. Meaning from number 21 to number what? To number 30. So this n here, meaning the number of what is the number of the period. Now in this case we say that here our n equals to what? 4, because they belong to what? To period 4. The noble gas is the noble gas before the period. So the noble gas before period 4 is what? Is argon. So we have helium, neon, then we have what? We have argon, meaning period 1, period 2, period 3. Then the next period is period 4. So the noble gas before the period 4 should be our noble gas here. Here is our noble what? Our noble gas. So since we are dealing with transition elements that belong to what? To period 4, now the element before the last noble gas before the period 4 is argon. So let me say our noble gas core here should be what? Our argon, AR. Then now here we have period 4, n equals 4, we have 4s2. Here we have argon number 18. Then here you have what? 4s2 here, 2 plus 18, 20 complement to calcium co. Then we have what here we have 4 minus 1 d to the power of what of x. This x is the what number of what? Number of electrons go? Number of what? Electrons. So from here we can say that the 3D series has an electronic configuration of what? Of argon co Ar 4s2 4 minus 1 here is 3 co 3d to the power of what? Of x. So now we are going to use this electronic configuration to drive all the configuration of what? Of the first what? Of the first period of the first series of what? Of transition metal that is from scandium to zinc.